Awesome. So, hi everyone. Thank you for tuning in. This is the eighth of 20 episodes of the Misplaced series. For those of you that don't know about Misplaced is a series that looks at misplacements and problems in the food systems and lets entrepreneurs and other experts talk about the solutions. So today it's a really exciting episode for us. We have with us our CTO from our Austria office, Thomas Riel, who is here to talk to us about insect technologies for food waste management. Hi, Thomas, and thanks for joining us.
Hello, nice to be here.
Thanks. So before we start, Thomas, I'll just tell our audience a little bit about you. Thomas has a very interesting background with a solid education in electrical engineering, biomedical engineering, and mechatronics. And he also has many years of experience in the implementation of R&D projects in both professional and academic areas. At Livin Farms, Thomas is responsible for conception, planning, and technical implementation of our insect-based waste management technologies. So today, Thomas will explain to us how our team is working on cutting-edge technologies to harvest insects while recycling a variety of food waste types. So we will learn a little bit more about why insect technologies are particularly efficient solutions in waste management, and we'll also get a sneak peek on current developments at Livin Farms. I'll also like to remind our audience that you can submit your question through comments or through the chat, because in around 15 minutes, Thomas will address them for you. So Thomas, without further ado, I'll pass it on to you.
Okay, thank you very much. Okay, so it's the 8th episode already. So it has been quite some information that you guys are getting. And now it's my pleasure to talk a little bit about insect technology for food waste management. So I will jump right into by introducing a little bit myself. So where I come from and what I have been doing the last decade, actually. So on the very left, you see this drawing from Leonardo da Vinci. And this is something that kind of inspired me very early on to acquire knowledge about pretty much anything. So this is actually why I chose a technical education. And then in the middle of my university studies, I actually then shifted my focus a little bit to also include medical education into that curriculum. And at the end of the day, I ended up studying biomedical engineering, so which is a very diverse mix of all disciplines. And this more or less, I think, gives you a lot of information about myself already. So I'm a generalist. I want to know about everything, but when it then comes to really the nitty-gritty details, then I more or less give the stage to more specialists. Then in the middle, after graduating from my biomedical studies, I actually went on to pursue one of my other passions, which is aerospace engineering. So this is a complete shift again in my education, and I joined a team of students at the Technical University of Vienna, which were building experimental rockets. And here you can see one of our rocket launchers in the US, actually, where with this two-stage rocket, we tried to achieve a new record going to 100 kilometers in height. Did not work out, but it was very fun doing these projects. And also then from this aerospace engineering, I wanted to go even further, and this is why I got involved in the first Austrian satellite project, also done with the same group of people, more or less, plus another university, and with more than 4 years of development time and approximately a budget of 2 million, we were finally the first Austrian team to ever launch a satellite, which was really great. And the satellite is still in orbit and sending signals, which is a huge achievement after 5 years now. And then more on my professional education, I then pursued a PhD in mechatronical engineering, and as my project during my PhD thesis, I was actually working with optical astronomy and doing high precision satellite tracking for laser communication. So this is a very specialized topic, I must say, but was a lot of fun doing that. Okay, so how does that all fit with insects? And more or less, here comes the answer. So I actually met with our CEO Katerina, in 2019, just out of coincidence, doing a project at a befriended company where she was, by any chance, just renting a space there. And this is how we got to know each other. And from there, I got more interested in insects and all the problems that they might solve for us. And here you see a few of the impressions that we were faced with in the first couple of months at Livin Farms. So when we were doing actually a project with a big retailer, the company is called Lidl, and here on the top you see actually how food waste actually looks like. So it's not the typical kind of food waste as you would imagine, but it's a very diverse waste actually, which then creates a lot of problems. And in this case in particular, we're actually focusing on bread waste only. And by first looking at this problem, we then came up with potential solutions. And you see me there on the lower left, where we designed the first robotic systems at Livin Farms, which we were at this time pursuing, where we were pursuing a completely modularized system to actually then automatically process and process all of this waste that the retailer had. We tested that system, and then came more or less again a little bit of a shift for us. Instead of like pursuing this further, we got back to the drawing board, and there in the middle you can see actually Katerina, our CEO, thinking very hard about that problem in particular. And this was one of these countless evenings or days of hard work and like reimagining how we are going to tackle this kind of problems. And at the end, we think we found a solution that can actually work. And with that solution in mind, we got get together again, tried to get some really good funding opportunities, which were provided to us by the European Union actually. And with this funding in the background, we were then finally able to make this first huge step in scaling up by moving our office to a completely new facility, and that you can see here on the bottom right corner, which is now our current facility where we're building our pilot plant at the moment. Okay, I think I will skip this a little bit. So Livin Farms was introduced to you guys before. This is like the small story behind our company. So founded in 2015 in Hong Kong, having two main business streams. One is educational, where we do the Hive Explorer and the related educational curriculum. And then the second stream is where we focus on really the industrial technology. And 2021 will be an exciting year for Livin Farms because we are finally launching a new product, which will be our Hive Pro, so the product for our professional customers. Okay, so then without further delay, let's focus on the topic ahead. So I was asked to speak about insect technology for waste management. Instead of jumping right into that, I actually want to do a little bit of extra session, and first talk a little bit about technology itself, because a lot of times people in the sustainability field do not really accept technology as a solution for climate change or a solution for sustainability at all. And I want to pick up a little bit and just briefly discuss that topic before I then jump into insect technology and waste management. So here you see a nice impression from actually the region where we are here in Europe. So this is the Central Alps. And here you can see two pieces of technology that, in my opinion, are a big part of a sustainable economic solution, but which are both very, very controversial to many people. So the one is the dam, so the hydro power plant that you see on the left, and the other is the wind turbines. Both of them are sustainable, in my opinion. Both of them are seen very critically by a lot of other people, and this kind of gives you an idea of what is the problem when we talk about technology for sustainability. Then another example, just to give you an impression how delicate this discussion can be. This is a electrical bike, it's a bicycle where someone decided to fit an electrical motor to. There's also a lot of controversy about this mode of transport, how sustainable it is, if it's not more resource depleting than just using plain bicycle. And I will not give an answer to that. Good idea. Problems we should always keep in mind, is this technology actually not making the problem worse, the overall problem that we are trying to tackle. And that these kind of problems are not always in plain sight, and in our digitized world actually often hide behind our smartphones. Bitcoin, I think, is the best example for this. It sounds like a wild idea which does not really do a lot of harm. It's just a few people buying into a crazy idea. But at the end of the day, they are really doing a lot of harm by pursuing that. And this is like the number of energy that is used just to keep this network working per year. And to give a perspective, let's compare it to actual countries. So on the left, you have the Republic of Austria, which we are based in. So Bitcoin is using twice the amount of energy as our entire country does. And the next best example actually in Asia would be Malaysia. So Malaysia, with its entire population and its entire economy, is using about the same energy per year as this network does. And there is always then the bottom line, which one should keep in mind, and that is how do we generate that electricity. And there I did a small comparison. So you would need to build the crazy amount of about 24,000 windmills, not the small ones, but actually the big ones, to actually power that network, or around 36 coal-fired power plants, which is not a thing that, in my opinion, is a good idea. Yeah. So I think I will not go into more detail about this this entire topic. It's very controversial, and really, when we as engineers develop a technology, it's not really our responsibility to think about all the consequences that that technology could have or implications, but the responsibility falls to us as a society, which we, of course, as engineers are part of. And we as a society should think very hard about how we deploy these technologies that we are developing. Okay, Now let's skip the technology part for the moment and look at our urbanizing world and the waste that we are generating in these urban centers. And here you see a nice impression of Hong Kong. And as you can imagine, such a city, such a mega city is producing a lot of waste. And then with that waste, we generate a lot of problems. So first of all, it depends a lot on how that waste is actually processed or how that is presented. And here you see an impression of how that in some parts of the world is still mostly done, just a big dumping ground. And by doing so, you take this waste, which at the end of the day was just a few minutes before it was waste. Actually, it was a very valuable resource, and a lot of energy and resources actually went into producing that waste. And it is our responsibility as a society to try to use our resources as good as possible, and that also, of course, includes the waste itself as a resource. And here on the bottom, you see this small pyramid. That actually gives you an impression of what is the current way of dealing with waste. So you have more or less a desired way of dealing and you have an undesired way of dealing with waste. And this pyramid tells you of how you funnel the waste through the waste management system. So first of all, of course, we should reduce waste as much as possible. This, for the food system in particular, this means not throwing away food at all, just eating it, even if it's a day or two above, beyond its date where it's still good to eat, or yeah. Then, of course, we should reuse. We should try to reuse the waste, give it or recycle it, or recover as much from the waste as possible. And only after we've done all of these steps, then we should think about how to dispose of it. And this is now the moment where insects come into the picture of waste management. So insects, together with microbes, are nature's choice of waste management. We as humans have deployed the microbial technology for waste management for a long time. Actually, this is how biogas digestion works. This is how composting works. And the insects entered the field just probably a decade ago to be actually looked at from business to be deployed as a potential solution for waste management. And there is, of course, a wide range of species. So there is, uncountable numbers of insect species out there. And in the industrial field, only a handful of them are actually used. And you see here one of the most popular, which is the black soldier fly. And this insect in particular is very well suited for waste treatment and is also the focus of Livin Farms. And insects can play numerous roles in the waste management. First of all, they can actually reduce the amount of waste. So insects tend to eat stuff, of course. And the lowest hanging fruit is really to just feed biological byproducts or waste to insects. The insects will consume that waste, will grow from it, and what remains or what comes out after the insect is already a huge reduction. So we see when we feed a ton of waste to the insects, we see a reduction in the amount of waste that is then left after the insects are gone of 70%. So this already reduces the amount of waste we have to handle by a lot, and by itself is already a good solution in our opinion. Then, of course, insects, by eating these biological products, they, of course, filter out valuable substances that are still in there. So they accumulate protein, which by harvesting the insects, we can then use to recycle it in our feed system and food system. So then we have already closed the loop. And then there is the last option where it's really the recovery of stuff that is in our waste, where insects can play really a fascinating role. And this is not so obvious for most people, but let me briefly explain how they can actually do that. And this is by actually feeding them. So a lot of the times you have the problem with waste management, or with waste in particular, that it's not dry enough. So there's a lot of excess water in the waste. And insects can serve as a biological heating system. And everyone who is involved in industrial processes knows that one of the most energy intensive, if not the most energy intensive step in pretty much any industrial process is actually drying. And to dry a substance, so to evaporate water, you need heat, and you need a lot of energy to generate this heat. And insects can actually use the waste to heat it up, and by that dry the substance for us. So this is a real, I find, a fascinating approach to waste management. And you actually do not have to use the insects afterwards for feed purposes, but you can actually just dispose of them. And by doing that, you reduce the amount of energy that you need to manage this waste by a lot, and also reduce the amount of waste, as we heard before. So this is an impression of how a modern insect facility actually looks like. So it's industrial process technology, and yeah, so there is not really any farming component to it. And we at Livin Farms have been working on this issue and this technology for the last 5 years, or even more. Now it's 6 years already. And now I want to quickly tell you a little bit of what we at Livin Farms are actually doing to develop innovative solutions for insect technology in waste management. So this is our current approach. We call it the Hive Pro, Hive Professional. It's a modularized facility, which is a plug-and-play solution that should be easy for any customer to implement. And we see insect technology really as a means to an end. So we do not want that the typically a customer who has a waste management problem and is looking for a good solution for it. We don't want this customer to be able to spend 5 years on entomological research and employ 5 PhDs to actually do that research for him or her, but we actually want to provide to the customer a plug-and-play solution that is simple, and he or she can just implement as simply as buying a machine. And this is the solution we think will achieve this goal. So it consists actually of a modularized of modules. Number one, so it's always kind of the same system. You have a kind of feed source, which would be the biological byproducts. This feed needs to be treated most of the time to actually make it viable to be fed to the insects. Then we have a service module, which is actually the hub in our system. So this module does all the handling. So it's an automatic system. It does all the handling of the trays, the insect rearing trays, which is the home to the insects. And it also does the dosing of the babies as well as the harvesting for us. And then we have the rearing module, which is really so we kind of plan our system for an urbanized setting. So this means that we have to be space efficient. This is why we chose to immediately go into the third dimension, which means height. So we have a multi-layer storage system that is fully enclosed and fully automated, so to make it as simple as possible for the customer to deal with this. And then at the end of our chain is the processing module, which is very customer specific at the end of the day. And this module does more or less the refinement and processing of the insect larvae as is desired. And the output is pure protein powder, the crude fat, and fertilizer that can be used to fertilize crops again. So this gives you a short impression of what we are at the moment really doing at Livin Farms and working on. And this is now an abstract view of where we think the biggest problem at the moment are in the insect field. And this is first of all the degree of automation. So we are located in Central Europe, and labor costs are very high for us. This is not in that degree true for other parts of the world, but also for most urban centers, this holds true for the most part. So automation, in our opinion, is key to actually run a facility economically. And the second point, which also kind of plays into economics, is efficiency. And here we are not only talking about energy efficiency, which we are absolutely obsessed with. So insect technology must be a solution for the underlying bigger problem. This is sustainability. And we cannot work in the same way as the overall industry is working. So we need to focus on efficiency, energy efficiency as much as possible to actually per kilogram of processed waste or per kilogram of output that we achieve a smaller environmental footprint by a big margin than the second best solution, which would be conventional waste management. And then on the very right, also a big focus from us is simplicity. So this means giving the customer a solution that is plug and play and lowering the bar as much as possible so that fast and easy adaptation of the technology is actually possible. And you already see that all of these three components that we are tackling at the moment, they have one simple goal in mind, and that is to make insect technology scalable. And scalable means that we have to use market forces to actually be able to scale. And at the end of the day, in our current economic system, this means we need to be better and at least as costly as all other solutions. So bringing costs down, bringing operating costs down, and still providing the best possible quality of the output products is key, so that this technology does not only stay a pipe dream, but really gets adapted and gets scaled up. And for that, we will need, of course, the help of others. With this kind of thinking, I also want to pose like a question. So is insect technology actually an interrupting technology, or is it a disrupting technology? And I cannot give you an answer at the moment. We are, of course, trying to make it a disrupting technology and try to make it scalable. And with that last impression that comes back to my past, I want to now leave you guys, and I'm now open for any questions that you might have. Thank you.
Fantastic, Thomas. Thank you so much. That was such a nice and informative presentation, and I like the last question. I'd like to hear what are the thoughts of the audience on interruption and disruption as well. We have a couple of questions from the audience. Before we get to those, one that we think our audience would be really interested in, and something that we talk about pretty often when we talk about insects. More often than not, they're seen as a nuisance, as a bit of a problem, something that people don't want to be around. And so here we're combining things like waste, insects, droppings, fertilizer. So when it comes to solutions of food waste, why should people prefer and find more convenient to work with things that crawl or fly instead of composting?
Mm-hmm. So it's really comes back to this pyramid of waste management, I think. And composting, for example, is a solution that works very well, and it also generates a nice output product, but it's quite low in the pyramid, I would say. So this means insect technology can work at the higher level of this waste management pyramid, and therefore is of course preferred just from an efficiency perspective. And at the end of the day, if you visit a state-of-the-art waste treatment facility, you will see that this is not really a very pleasant place. And I'm quite sure that 99.9% of people of this planet have never stepped a foot or never stepped into such a facility. So I think that it will matter very little what kind of technology is really behind it. It really matters what is the output. And also we have at Livin Farms here, we are very much focusing on making insect technology really plug and play and really a black box solution. So the user of this technology should not really be, should not really get to know the insects kind of. So they should be just in a black box in a machine-like system where they grow and and do their thing, and the user should not really actually see what is inside. So then is, I think, a very little problem. Of course, the other thing, and this is not really something we talk about in this session, when it comes to insects as a food source, then of course the discussion is a different one.
Yeah, of course, and we could go on and on that one as well. Thank you for that answer. I like the idea of a black box solution where one does not necessarily need to see what's going on if they're worried that it's not pleasant. So let me maybe pick a question from the audience since we have a couple coming in. One from Null. What is the biggest challenge in figuring out the engineering for this type of technology, as it is somehow unique and combines not only engineering, but also biology?
Yeah, so this is of course true. It's an interdisciplinary field. And the biggest challenge is actually, so we kind of can separate the insect technology in let's say 4 different topics. So the one is actually the feed treatment. Then we have the biology. Then we have the harvesting, and finally the processing of the insect larvae. Then you could also include the reproduction, which I for now would add to the biology. And most of these things are figured out pretty well by other industries. So the things we are doing is not entirely new. Most of our systems we can actually pretty much buy off the shelf from other industries. So this is of course very convenient for us. But of course this interface between the insect biology and the technology is a little bit of a challenge. But at the end of the day, it's really only, and this is only process engineering. So if you ask an engineer that is doing other biotechnology, for example, so rearing microbes, so they are faced with pretty much the same problems. Or when you talk to farmers, for example, in the poultry industry, they are pretty much faced with the same problems. Of course, our solutions are a little bit different from these conventional solutions. So our solutions are different from standard biotechnology and farming, but we are kind of in the middle of the two, and we try to reuse as much as possible from these two fields. And to answer the question, what is really the biggest challenge? I cannot really give you one at the moment. It's I think it's the system engineering, not the engineering, the individual engineering parts, but actually getting together the entire system. And then, yeah. Okay.
Thank you, Thomas. Yeah, I think it answers pretty extensively. Thanks for that. And I'm just going to move on quickly because we have a bunch of questions coming through and they're all pretty interesting. So I want to make sure that you get to most of them. We have one asking, why is disruption technology, how is disruption technology different from interruption, and why it is such a key aspect to be disruptive and not interruptive?
Yeah, I would say that the time horizon is the difference. So an interruption is like a short event. So you have a hype, and then after the hype, the interruption is gone again, and then you continue with the way the status quo of doing things. And the disruption is a permanent change of the system. And this is why I say we do not, as an industry, want to end up being just an interruption. So a short hype, and then after a couple of years, more or less, the industry dies off again because it was not a viable solution. But we actually want to be disruptive and permanently change the way of doing things.
Thanks for that and for the good question. The next one, what kind of processing is usually done to make the feed viable for the insects, and what is most important for you?
Mm-hmm. So it depends a lot on what kind of input materials you use. But at the end of the day, you can more or less say it starts actually with logistics. So you have to kind of find a good solution to bring it to your site and to store it on site and to make it storable so that it does not get bad during the time that you need to store it. And then it's really, it comes back to the industrial treatment technology. So it's cleaning, separating, so to get out everything that should not be there, like removing plastics, removing metals, and then it's homogenization, so to make it a homogeneous feed substrate. And then you most of the time can also include a step where you stabilize it. So this means that you kill off anything that would, any thing that you don't want, and a biological insect, for example, or microbe that you do not want into that substrate source, because it could cause a problem in the system afterwards. This is mostly done with a little bit of heat treatment, for example, and then it's already dosing. So then you mix it, or you first of all, you also most of the time need to control the moisture. So this means removing or adding a little bit of water, but then you're pretty much done and you can start the dosing into the rearing trays.
Fantastic. Thank you, Thomas. So we probably can take one more question. And I'm going through all the questions here. And I think what would be interesting is probably the one from, I want to say Guillerme or Guillaume. I'm sorry if I'm butchering your name, not doing it on purpose. There you go. So who is your main customer focus, and who do you think will be investing in this system to use it in urban centers? And if I may add, because I think you might be able to answer that together with this one, that was a note that we had as well to ask you about basically the size of food waste that is ideal for this system, and therefore the size and the type of businesses. Yeah, thanks.
Yeah. So the kind of customer, it's basically what you want to have is a customer which has a stable and a stable and convenient source of feed for your insects. And this means for most of the time for the customer, he does not or she does not see it as feed, but he sees it actually as a waste. So you need a customer who has a waste source that is reliable. So it comes reliably every day of the year, be it winter or be it summer. It has to have a pretty stable quality, I would say. So this is the ideal case. And then it should also not have, it should be in a form where the insects grow well on it. So you do not want, of course, waste sources that are toxic in any form. So this is kind of the outline of what a customer would look like. And there are a couple of such customers around. So it starts, for example, with retailers. So retailers have the problem that not everything that they put in their stores is actually sold. And by regulation, they have to remove it at a certain point, and then they end up with unconsumed food. This is just one example. The second would be food processing facilities. So they have in their processing, when they have an input of several products, and they then process that into something different, be it, for example, a food that you can then buy as a customer, or be it actually also feed. So there's also feed producers, of course. And in that process, there's always steps where you have some waste. And this is most of the time a very valuable product still, and that would be also an ideal customer. And then what else comes to my mind? I think that is already a lot. So if these kind of companies are not so, you do not see them a lot, but there are actually a lot of them around, because these are the backbone of our food system at the end of the day. And what size is ideal? I think there is three fields, or the industry is actually currently working in three segments. So one is the very small segment, which is something on the scale of a big farm. So farmers are also, of course, food producers. They also have byproducts. They could also be potential customers. But a farm is really, in this industry, is a very small entity. So it starts there with a farm size customer. And then you have on the opposite side of the industry, you have this very huge segment where you're building really these gigantic facilities that process not hundreds of tons, but tens of thousands or to the hundreds of thousands of tons. And this is really the kind of technology that's involved there is very industrial, very high tech at the end of the day, and very costly. So the capex is so the capital expenses that you need to invest is in the tens of millions upwards. And then there is this third segment that is right in the middle between the two, And for us as Livin Farms, this is the segment that we want to deal with. And this is really the segment of a company, a food producer, a feed producer that has a waste source that is big enough for him to be a problem where he or she is looking for a solution, but which is not of a size where it makes sense to build such a huge facility. So we are right in the middle of these two extremes, and I would say something in the range of be it 10 to maybe 100 tons of input material per day. This is the range where we feel that a lot of customers are, and where it's also able to run this facility economically, because this is of course the second point. The one is how much do you have to invest, but then on the other hand, how much does it cost you to run the facility? And there you see, of course, scaling effects, and these scaling effects are really important to be economical. And this is, in our opinion, also the problem with these farm level solutions, that you cannot really run them in an economic way. Yeah. I hope that answered that question.
It does.
Yeah. Thank you.
It does. Thank you. Thank you. So, yeah, thanks for explaining where's the sweet spot for Livin Farms, and also the difference in efficiency across these levels. This is really cool for all of us, and really interesting also for our team here in Hong Kong, I think. There are other questions, but unfortunately we're running a little bit too over time. So we'll note them down, and maybe make sure to respond through our newsletter or other ways. So I'll have to close the episode here. Thank you so much, Thomas. And before we go, I just want to remind our audience to tune in next week as well. We'll have another conversation around food waste and solutions to food waste with Philip Schuler from Too Good To Go. So make sure to register for our series to receive these updates and reminders. And yeah, make sure that you register also to receive links to the recording videos. And finally, we have a couple of gifts for you. I think Selina is sharing with you a $30 discount for our web shop. And if you feel like you want to wait a bit longer and you feel lucky, we will also have a lucky draw at the end of the series for a $150 gift card for our web shop. So once again, thank you so much, Thomas, for this episode and for your talk today. And I'll see you everyone once again next week. Thanks.
All right. Thank you very much. It was my pleasure.